Alright, engineering evaluation airflow method with the investigate the safety aspect of the flow measure for the brake pipe leak for the investigation address the potential problem with associated with the calibration accuracy of the airflow meter. Possibly the airflow meeting fail will indicate the success of the leakage air and analysis with the compare the leakage measure for the airflow meters. Current pressure drop leak with the measuring type of this air with along with the relative reliability advantage with the disadvantage of the two methods discussed for the following section. Airflow relationship with the in order of the appreciate for the engineering and analysis of the airflow into the one must first address the basic relationship with the compressible fluid flow with the contact with the metering orifice with the nozzle. They are found with the Mark's handbook. 20 represented reference 21, 22, and 23. Airflow method the reference for the made volumetric flow width of the standard cubic feet per minute. Pressure of 14.7 psi and with the temperature of 60 degrees Fahrenheit, either stay with it implied with the sense air pressure and with therefore with the air density of the chain with the different points for the brake system similar due to the weighted rate mass rates of the airflow with the primary relation with the compressible flow is weight rate of flow in pounds per square inch equal to flow of the efficiency with the width of the function of the Reynolds number which is the air density, velocity, the time of pipe diameter divided by air velocity times the net expansion factor, which is the function of the pressure ratio, and then by orifice area in inches squared, and then times the gravity control of the 380 inches a second squared by the square root of 2 to density of the upstream air pounds and inches quartered, and then times under the radical pressure drops across the orifice nozzle P1 minus P2. Using standard density air, the equation B41 must be stated in terms upstream of the pressure, and it shows the weight of the rate over the airflow, 0.86 psi. Three possible metering configurations are sketched below, along with the representative value of C and Y. The flow of the calibrated device for the particular application airflow method, and it shows the sharp edge orifice of the nozzle, elongated hole. Three types of metering devices, and airflow high flow rate for the pressure rate across the metering device the P2 over the P1 less than 0.53 sonic choke with the flow of the control of the exist. Flow can exist if the fold of the nozzle rounded entrance hole of this become a limiting flow rate independent of the downstream pressure. However, the phenomena has not been observed with the test with the sharp edge or with the 2023. The airflow relationship between the metering input with the 3 points for the airflow method for the first for the metering or for the A19 and adapter for the curve for the flow with the measured second with the calibration of the device for the finally with the various brake pipe leaks. And the measurement of the calibration system is sketched in figure 4.2 for the airflow meter. Shows from the main reserve into the or for the 1964 or as the airflow meter 2.6 brake valve with equipment, and then control brake pipe pressure with the brake pipe calibration device into the atmosphere. Across the airflow meter with the pressure gauge with the orifice of pressure with a drop of roughly 10 psi, particularly with the 60 standard cubic feet a minute flow rate with the pressure ratio with the P to 2 the P2 over the P1 092 for the 093 well above the calibration ratio. The expansion factor over the Y 097 over the 098 and 22 for the curve for the calibration device over the critical ratio for the 4 XC for the geometry condition of the tolerance for the metering device, but come with greater importance for the deviation from the sharp edge or for the geometry can result in the choke with the flow with the effect with the reliability with the calibration. A high flow rate for the pressure relating across the metering device is less than 0.53 sonic choke with the flow with the nozzle with the round entrance hose or with the become a limiting the flow rate and independent with the downstream with however the phenomena has not been observed with the test and sharp edge orifice for the 20 and 23. Flow the relation opposing the metering and important with the 3 points for the airflow method of the metering off of the orifice of the A19 adapter called for the flow. Measure second calibration of the device with the finally various brake pipe leakage with the measured calibration system sketched below in figure 4.2. 4.2 shows the sketch of measuring calibration from the main reservoir into the orifice of the 1964 of an inch of the airflow meter. 26 brake valve with an inch for the control of brake pipe pressure, brake pipe or calibration device in the atmosphere. Across the airflow minute, the pressure gauge for the oar for the pressure drop with a roughly 10 psi, typically 60 standard cubic feet a minute with the flow of the rate. The pressure ratio for the P to P1 with 0.92 for the 0.93, well above the critical ratio for the expansion factor Y 0.97 for the 0 for the 98. Across the calibration device, out for the critical ratio as far as for the gravimetry condition of the talents for the meter device and have to become grave with the importance of the deviation over the sharpness of the oar for the geometry can result in the choke of the flow with the effect of the response and repeatability with the calibration. 4.2 air and of the leak rate tested in the currently used for the pressure top of the brake pipe with leak of the brake pipe. Pressure for the measure over the 1 minute time period for the minimum rear end pressure for the 60 psi gauge for the minimum pressure for the gradient and 50 psi gauge criteria for the minute 50 psi brake pipe so for the reduction of the brake pipe pressure for the mid with the brake valve lab for the pressure maintained with the function turned off the only drop of the brake pipe pressure for the time over the 60 second during the following with the 30-60 second period with the delay after the brake pipe appellation exhaust increases. A simplified formula will develop with the bend at the L for the pressure drop of the leak test for the various time of the environmental decay with the environment. The formula can provide with the sum of the instant and so for the various errors and factors inherent with the test. And it goes on with a crazy using representation value of the time leakage rate over the 5.6 psi in a minute with calculated increase for the delay time of 30-60 seconds. Over the brake pipe reduction application for the starting time of the pressure drop over the decrease for the ratio 5.3 psi a minute, about 5% air over the air is related to the watching for the during the time of the introduced air with roughly 1.5% per second. The extremely effective in this formula is shown with a vary with the square root of the absolute temperature, so with the fixed leakage for the warmer over the brake pipe air with the faster for the brake pipe drop above the example to remain over the ambient temperature for the negative 30 degrees Fahrenheit to 110 degrees Fahrenheit was increased leakage for the 5.0 to 5.8 psi minimum. However, the leakage for the valuation 418 varied with the inverse square root of the temperature. So the result of the equation 4.3 is questionable. For the pressure gauge of the air, consider the absolute with the air range of the air with the linearity, backlash, friction, and hysteresis, resolution air with the gauge for the typically range from 0 to 160 to 0 to 200 psi gauge full scale with a 10 psi made for the increment of 2 psi minor increments. Gauges are tested with the Burlington Northern 1 psi accuracy held with the plus or minus 3 psi all errors and operate with the full scale accuracy level effects with the measurement of the chain with the pressure drops. Pressure during the leakage test for the resolution interpolation of the errors of the more important may be typically plus or minus 1 psi. Errors may also limit the due for the gauge movement in the situation high stereo of the end tapping of the gauge to the face of the finger with it being necessary to ensure proper measurement of the engine for the vibration while pulling over the train with it normally provides sufficient dither to the gauge with the vibration lower with the level during the terminal brake test. For above, we can assume that 0.5 psi air for the bolt for the start of the 60 second per second Guerre readings, 0.4 psi air with the due to the delay with the time of the pressure drop timing. They can be combined with the time call for the total air with the brake pipe leakage measurement of 0.5 psi at a minute. Brake pipe leakage of the P plus or minus 0.9 psi RMS or 1 point plus or minus 1.8 psi work case at 18 to 36% error. More important, however, the time pressure drop will be directly proportional with the equalized brake pipe pressure, and which is lower than the normal brake pipe pressure for the brakes relief of the measurement. Therefore, the predicts the leakage rate with less than 19% lower than which of the brake pipe pressure with its normal level. 422 airflow method. The airflow method utilizes the pressure cube to measure for the pressure for the differential curve for the over the generator for the brake pipe airflow. Locomotive control valve with the train line figure 4.2 for the gauge for the typically range from the 0.15 0 to 20 psi full scale for the 1 psi mark with the accuracy within plus or minus 1/2 psi resolution 1/4 psi for the airflow with the 60 standard cubic feet a minute with the gauge tolerance translate with the air the flow with the accuracy of the plus or minus 1.5 standard cubic feet a minute with a 1964 the inch diameter or for the 60 standard cubic feet per minute airflow with the develop the pressure for the differential with the 12 psi with the airflow with the L15 psi gauge. Sometimes bypass the parallel flow with the knee with the set with the gauge at 8 with the mid-range during the calibration. The Explorer fixes several of the errors of the control of the method of measuring airflow. Will assume an example of the case with exactly 60 square standard cubic feet a minute or 0.0764 Pounds a second with the brake pipe with the main pressure for the supply for the moment with the ignore with the bypass valve with which for the reduce for the sensitivity airflow meter and chamber the U for the proper value for the flow of the expansion for the coefficient 1964 for the inch for the diameter sharp edge 4 fits 22 equation 4.1 may be stated as assuming the main reservoir pressure for the 115 psi gauge the temperature of 60 degrees Fahrenheit pressure drop to 12.1 psi will occur across the gauge at 60 standard cubic feet a minute. 42221 effect for the main reservoir pressure for the air compressor for the freight locomotive typically cycle with the 10 psi range cutting with the main reservoir pressure drops to the minimum setting with a minimum within 100 psi gauge of the Burlington Northern 130 psi gauge Canadian National variation airflow meter reading of the main reservoir pressure given them with the table below in 481 4841. Look at the main reservoir pressure variation, airflow meter pressure reader gauge, the P pressure reader gauge, 115, 125, 130, 140. Your PSI gauge at the pressure cubic feet a minute and percentage air yield. These apparent changes in the flow will occur if the locomotive air compressor cycle with the off, and even if the 60 standard cubic feet a minute flow remains of the constant. Alright, 422. The vacuum of the main reservoir temperature of the locomotive of the main reservoir, the air temperature range with the aim is somewhat with the aim depending on the hard compressed for the habit and work with the reservoir locomotive located beneath the locomotive frame with the directly exposed with the outside of the air, the shore of the air temperature with the easily range below negative 30 and above with 100 degrees Fahrenheit. Fill the main reservoir of the input area temperature for the shown in the figure 42 with the example assuming the fixed of the actual flow rate is 60 standard cubic feet a minute. Table there is apparent change of flow rate with the change of the temperature even though the assumed constant 60 standard cubic feet a minute flow rate with the however the given and leakage of the calibration device itself will show no change in reading but will change the actual flow rate with therefore the calibration shall read the same and no matter what the temperature with which is done. This assumes no change of the air temperature through the brake control valve within the brake pipe with no true mass flow indicator which will show the actual change of flow and the temperature. 4.2 show the effect of the main reservoir temperature variation of the airflow measured pressure reader gauges and note for actual flow of 60 standard cubic feet a minute. 42223, the effect of the barometric pressure for the no variation of the barometric pressure for the due to the weather condition ranging from plus or minus 1% of the sea level. 50 for the change of the absolute main reservoir of the brake pipe pressure for the ignore for the change of the altitude with however the can substantial. 10,000 feet with the altitude with the pressure ratio with the 0.687 and the effect of the change cubic feet with exists. Effects for the airflow measured within the pressure gauge given in the table 4 for the leakage for the however the effect of the lower change atmospheric pressure. The sum of the total leakage for the choke valve for the sum of the brake pipe temperature for the pressure for the 80 psi gauge for the example of 60 cubic feet. If you standard cubic feet a minute leakage at sea level would increase 57.1 standard cubic feet at 10,000 feet elevation. Table 4.3 show the effects of the barometric pressure variation, airflow measure, pressure gauge readings. Alright, 4.224 effects of the humidity, moisture of the air, of the minor effect for the density of the air, for the airflow, for the low influence of the thermodynamics of the airflow method, the node of the sharing air, with the 14.7 psia, 60 degrees Fahrenheit, ignores humidity with the normal air, defined with this 14 psi with the 68 degrees Fahrenheit with the 36.9% relative of the humidity, some of the moisture for the remove of the sort of the air, compressed for the insert stage cooler tap. Either enough moisture remains in the air, however, the cover the problem that the strain of the brake system extreme and cold temperatures. None of the problems have been associated with the airflow method. The airflow testers 423 airflow calibration, airflow meter calibration proceed with the discovered previously in section 3.3 with the needs of the calibration mark. The lowest main reservoir pressure, the pressure rising has been emphasized with the effect of the varying of the main reservoir pressure airflow measurement is shown with the table 4.1. Which air 3 to 4% of the can be introduced within calibration. Brake pipe with the air temperature for the strong and effect with the actual flow rate through calibration device, assuming the published for the value of the CMY with the ASM sharp edge or for the 2021, 22, and the phenomenal proceed with the condition of the calibration Burlington Northern Canadian the actual flow of the variation can be calculated, and they are given the table of 4.4 and from test reported of the Burlington Northern. It appeared for the actual CY value slightly lower than the published value of the airflow with the calculation bug Dictating the 26C control valve and maintain with the brake pipe pressure for the desired 80 to 75 PSI gauge respectively noted with the previous section airflow meter will indicate with the same with the independent temperature for the cover the compensating effect of the orifice pressure for the differential range of the calibration however the would be an error of the actual flow rate is proportional to the over the table the 4.4 for the reason for the calibration devices must be certified calibration itself with a lower temperature for the minimize for the reading error for the cold weather the leakage problem with the accentuated and for the reason the AAR calibration proceed with the RP 402 for the 6 402 figure 3 4 require with the device at 60 standard cubic feet a minute with a flow rate sometimes with not exceeding 20 degrees Fahrenheit. Calibration device if it must be treated with care because of the air, dirt with the damage nicks for the orifice the edges cause significant change with the flow with expansion of coefficients constantly change within calibration airflow. 4.3 airflow meter accuracy requirement. The AAR mechanical division issues specification airflow meters for the manual standard recommendation. Practice airflow indicator specification M980 and M980. Effective January 1st, 1989. Specification M980 includes appendix A of this report. In these specifications, the device must be accurate with a plus or minus cubic feet a minute, airflow rate of 60 cubic feet a minute in section M980, section 3.3. In section 422 for this report, flow accuracy for the plus or minus 1.5 standard cubic feet a minute, calculated based on typical pressure range, errors and flow rate of the 60 standard cubic feet a minute without the flow pressure measured for the pressure differential across or its flow dependent with the really important fact with the main reservoir air pressure minimum setting and cycle range of 0 to negative 2 cubic feet a minute with the air of the over compressor cycle with the main reservoir air temperature plus or minus 2 cubic feet a minute over the reasonable temperature range, altitude plus 1 cubic feet a minute at 10,000 elevation. These errors combined to give the total errors of the range with the plus 4.5 cubic feet a minute to negative minus 5.5 cubic feet a minute with a nominal of 60 standard cubic feet a minute with the RMS probable error with the plus or minus 2.7 cubic feet a minute. Therefore, with the currently used with the devices cannot be restricted to the same of the AR requirement. Orifice flow with the expansive coefficient of the C and Y tend to increase with the lower flow velocity Reynolds number, the lower pressure for the drops, which add for the basic nonlinearity. Current airflow with the meter for the air is however the wood air dominantly only air it flows less than 5 standard cubic feet a minute. Alright, 4.4 airflow meter reliability. Currently, both the leakage rate for the airflow test method, the must be standard pressure gauge with the qualified for the train brake system for the long for the experiment of the pressure gauge that are known for the high reliability in terms of the gauge via the airflow method required for the chain with the 92-day inspection cycle. As over the air pressure gauge with the locomotive with the cab, the metering office for the airflow indicate with the path of the device except with the pressure relief function with a higher charge flow rate with no evidence for the past agreement with the airflow method of the problems with the airflow indicators. Therefore, in terms of equipment and reliability, both methods are comparable. And then it goes into the reference pages, and there's about 20 references, and then it goes into Appendix A, AR specification M980, and that was your evaluation locomotive cab airflow meters for train air brake leakage test report, FRA ORD, technical task number 4, testing.